Hello everybody and welcome to this unique video for Wall Street Osmium. This is going to be about attempting to precisely define which metals are the noble metals. So basically I'm going to be getting out the old baseball bat and whacking the hornet's nest with it because I'm sure there's going to be some conflicting opinions about this. And while a good chunk of this video is going to be highly biased on my part, there's another sizable chunk of it that is much more open-minded in terms of, what's a noble metal and what isn't. Uh, so here we go. Let's get the ball rolling. Okay, guys, so what we have here is Wikipedia's opinion on what is considered a noble metal and how often it's considered one. So let's look at this little diagram here. In green, we have most often, consisting of ruthenium, rhodium, palladium, osmium, iridium, platinum, and gold. Yellow is often, consisting of silver. We'll get back to this one. Red, consisting sometimes of copper and mercury. Blue, in a limited sense, consisting of technetium, rhenium, arsenic, antimony, bismuth, and polonium. So, let's go back up here and start hashing this out. Copper. No, it isn't. That is not a noble metal. Mercury. Also not a noble metal. I don't care what you say. Arsenic isn't even a metal. It's a metalloid. If you're going to be a noble metal, you have to at least be a metal first, so you're out. Antimony is also not a metal. You're out. Bismuth is a metal, but it's not noble, so it's out. And polonium, don't even ask. Technetium, don't even ask. Rhenium should be upgraded to often because its corrosion resistance is pretty darn similar to osmium. Historical Marine 45 is tested entirely with rhenium. I haven't done any tests with rhenium, but trust me when I say it's pretty similar to osmium. And it's very important for airliners. If we didn't have rhenium, airline prices would go way up. No doubt about it. Now, silver. You have no place on this diagram, and you guys have no place on this diagram, nor do you. These guys right here, noble metals. Well, this one sometimes can be considered one. Sometimes. Copper, mercury, no. Technetium, no. No. Don't even ask. Okay, so I'd like to go back to this little legend right here. A star may be tarnished in moist air or corrode in an acidic solution containing oxygen and an oxidant. Cross attacked by sulfur or hydrogen sulfide. As you can see, silver is both starred and crossed. However, it is attacked by more than just that. Now, what you're about to see is a montage of me taking a fine silver bullion and putting it through its paces. The sheer immediateness of the reactions you have to see to believe. Going back in. Shit. Oh no. Oh, that is not good. Shit. Alright, let's pour it out, see what the damage is. Woo! God, it smells like... Wow. Oh, the damage is very bad, I'm afraid. Oh my word, that is really, really bad. Wow. Okay, so silver is clearly out of the running, but what about the rest of the metals? How do we define what is a noble metal and what isn't? Funnily enough, I've been collaborating with the user Gamer of Red to organize a criteria for determining what is in fact a noble metal. This was mostly his idea, actually. Take a look at the initial original criteria. Okay, so take a look. This was the original criteria. In order to be a noble metal, the metal had to fit at least two of the following criteria. Does not dissolve in HCl, does not dissolve in HNO3, does not dissolve in alkali, or H2SO4, does not dissolve in aqua regia, is predominantly found in nature in its native metallic form, does not tarnish in air, does not form an oxide layer at room temperature, invisible or otherwise. Okay, so having collaborated as much as I have with Historical Marine 45, with all the tests that we've done, not just with osmium, but with many other metals as well, and the information that he gave me about them, I saw one or two improvements that could be made to this list, because there's a lot of metals that it doesn't exactly exclude. These would be metals like tungsten, tantalum, titanium, silicon even, and a few others that I can't quite recall off the top of my head. So he and I both agreed that a couple of amendments were needed to this criteria. The first one was that the metal had to fit at least three of the criteria, not just two. And the second amendment was that there needed to be an additional mandatory criteria that had to be met, which was that the metal could not dissolve in hydrofluoric nitric acid mixture at room temperature. So that gets rid of, metals like titanium, tungsten, tantalum, metals like that. So according to this new criteria, gold is included, silver is excluded, metals like titanium, tantalum, tungsten, niobium, etc., they're all excluded, and palladium just barely makes the cut. But of course, when trying to narrow something so subjective down to an accurate science, it really isn't that simple, is it? Because there's other criteria to consider as well. Palladium may only barely make the cut, but when you consider the first two tests that I showed earlier with silver, when I stuck it in chlorine in hydrochloric acid and bromine in hydrochloric acid, the thing is, gold and palladium both dissolve in those mixtures. The difference is the speed at which they react with it. Silver reacts immediately with it. Gold dissolves slowly in it, and palladium also dissolves slowly in it. So I think speed of reactivity is, also a factor. And speaking of complicating things, take a look at this little chart that I came up with. Okay, so let's start unpacking some of this information here. First of all, I probably should have used the words react with instead of insoluble due to the non-water solubility of silver's compounds. But all the same, silver does react with, most of these things on here. You'll see in the upper left-hand corner, palladium is shaded in yellow. That is because powdered palladium will dissolve in hot hydrochloric acid, and diagonal to it, in hot aqua regia, rhodium is shaded in yellow. And it's because rhodium kind of sort of dissolves in hot aqua regia. It dissolves really slowly. I've also read that rhodium dissolves slightly in hot concentrated sulfuric acid. I didn't bother shading it in yellow for that one because when I tested it, well, take a look. I did this test a while back. I bought a cheap rhodium plated necklace, and as you can see, it didn't go well. All the metal but the rhodium ended up dissolving unbelievably quickly, and then all the little bits of rhodium plating are just, floating around everywhere. Now, you will see in the um, section just to the right of that, insoluble in HF-HNO3 mixture at room temperature. That's a possible wrench in the spokes because we've never tested gold in that, and if it does dissolve in room temperature, then that would exclude gold, and then that would further complicate our definition of a noble metal. But, we could continue complicating this even more, so on and so forth. I even went through the trouble of organizing a completely separate chart showing different metals reactions with a mixture of hydrochloric acid and hydrogen peroxide. And I think this actually does a really good job of sort of, kind of-ish outlining where the noble metals kind of are. What it also illustrates is that people who once thought copper was a noble metal were clearly wrong, even if my brother disagrees with me. At the end of the day, though, in my opinion, these 7 metals make up the noble metals, plus rhenium, kind of. It really is a shame about silver, though. It has the most beautiful, brilliant white color to it that you don't find in any other metal. But unless you keep it in a safe place, it just doesn't stay brilliant for quite long enough.